Hello, everyone. Thank you for joining us today for our webinar. We are joined by John Olstik, who will begin the presentation with some strategic insights, and then Avi Chesla will continue in his discussion on cybersecurity operations. Enjoy.
Thank you, and hello to everyone. This is John Olstik, Senior Principal Analyst at ESG Fellow at the Enterprise Strategy Group. Welcome to the webinar. This is a topic that I have a lot of passion for. It's my focus area. I think we'll see some big changes moving forward. So if you can move on to the next slide, please. I'm going to set up our discussion with some research that we've done. And I'll start by talking about the current state of cybersecurity operations in analytics. There's a lot going on. Things are changing quickly. And I'll talk about some of the challenges and pressures and strategies that people have. We'll talk about modern requirements. So what's changing and what's required in a large enterprise setting. I'll introduce a concept that ESG has proposed called Security Operations and Analytics Platform Architecture, or SOPA. You may have seen some of my blogs or some other industry literature or industry discussions around SOPA. The thing about SOPA is historically we've used independent security operations tools. That doesn't work. And so we need to start thinking about integrated architectures. I'll talk about that, and certainly MPOW fits that model. And then the bigger truth is my summary and conclusion. Once I'm done, I'll turn it over to Avi, and then I'll hang around for Q&A. So if we go to my next slide. This is some recent research. And this research was focused on security operations, and we wanted to capture first what are the main objectives that people have with security operations. So here's the data. First of all, I'll make the observation you see a lot of things. So it's not one thing that stands out. There are actually many objectives that people want to achieve. Now, I should also say this was a survey of roughly 350 cybersecurity professionals working at enterprise organizations. Enterprise being characterized as 1,000 employees or more. So onto the data. What do people want to do? Well, first thing is they want to improve their ability to detect, contain, and remediate advanced attacks and insider threats. We all want to do that. But the fact that that's our objective tells us that we are short in that area, that we need help in that area. So we've made that a particular objective to improve. We want to improve our ability to discover, prioritize, and remediate software vulnerabilities. That's a consistent issue that I've seen for the 15 years I've been in cybersecurity. But we also want to improve the operationalization of behavior intelligence. And what I mean by that is we know that cyber attacks have a very long and distributed life cycle. So think of the Lockheed Martin kill chain, for example, or the phases of the MITRE attack framework. So we want to understand the behavior of attacks as they relate to the endpoint and the network and files and storage and communication to external entities and things like network activity. So we want to understand more, not just discrete alerts, but we want to understand what's happening on an aggregated scale. And of course, we want to add more intelligence to security analytics tools. We're seeing this as a trend in the industry. And why do we want to do that? Because things are too hard today. We get alerts, but we have to diagnose those alerts. We have to make sure that they're legitimate alerts. We have to investigate those alerts, prioritize the investigation of those alerts, and we have to remediate issues that we find. And so more intelligence in our solutions that eases that burden would be most welcome. So the question that really is obviously coming out of this slide is, well, how are we doing against these objectives? So if we go into the next slide, unfortunately, the answer is we're not doing very well. So here's a question I tend to ask in all my research. How are we doing relative to how we were doing 2 years ago? And what you see is that 27%, the blue bar, or the blue part of the pie, 27% of those we surveyed said cybersecurity analytics and operations is significantly more difficult than it was today than it was 2 years ago. And another 45% say that cybersecurity analytics and operations is somewhat more difficult today than it was 2 years ago. There aren't many professions where things continually get more difficult, but cybersecurity is one of them. So we have to maintain our education on the latest types of threats. We have to be very smart and efficient about how we detect threats, all of the above. But what this data says is we're not really doing that things are getting more difficult. And the obvious question here is, why is that the case? So if we go on to the next slide, please. Those that said that things were getting more difficult were asked a follow-up question. Why? Why do you say that? And what we see here is 26% said that the threat landscape is evolving and changing so rapidly, making it difficult to keep up with trends we need to understand for our security analytics and operations. So, to paraphrase, we're not keeping up with cyber adversaries. We don't understand the tactics, techniques, and procedures that they're using to attack us. We don't know who's attacking us. We may not even know the IOCs that they're using, which is sort of a basic step. So we're sort of in the dark about who's attacking us and what's happening on our networks themselves. Well, we've added a lot of detection tools, but those detection tools are resulting in these alert storms. And so 19% say the volume of security alerts has increased. Going back to the last question, making it more difficult to keep up with security analytics and operations. So more alerts isn't a good thing necessarily. More accurate alerts, yes. More collated or contextualized alerts, absolutely. But just raw, discrete alerts, not good. It gives us more work to do. We don't have the time or the resources to do it. 18% say we have gaps in our security monitoring tools and processes. So it's difficult to get a true understanding of security across the entire internal and external infrastructure. And that really speaks to the fact that the attack surface is growing. We're adding more devices. We're adding more cloud-based workloads. We have more data on the network, more sensitive data. And yet we have these gaps in security monitoring where we either have blind spots or we're not doing continual monitoring, thus making security analytics and operations more difficult. Now, there's some other data here about skills gaps. The cybersecurity skills shortage is not getting better. And then more traffic on the network. This contributes to, as I mentioned, the growing attack surface. So that's the state of things. Here's how we're managing security today. Now, this has been discussed in the industry quite a bit. People are using lots and lots of tools, so we wanted to get a handle on that. So this is just for security analytics and operations, so not endpoint controls, not things like encryption technologies, et cetera, just for security analytics and operations. Enterprise respondents, and it was 412. How many tools are you using? Commercial, open source, homegrown. You can see that 40% of those we surveyed are using between 10 and 25. And 30% are using between 26 and 50. And the sweet spot here was around 30 when we looked at the data kind of universally. So 30 tools to figure out who's on my network, to detect threats, to respond to threats, to investigate threats. 30 tools is a lot. And if those tools are individual, if they're not somehow integrated, that doesn't work. Now, what about a SIM? So people would say, okay, well, the SIM is the tip of the spear, isn't it? Well, SIMs strain in terms of their ability to scale. SIMs collect log data, but are not as strong on detection and especially isolating problems. SIMs are expensive and complex to use. So SIM technology has a place here, but SIM technology is also not the solution. SIM technology really just aggregates part of the problem. So if we go into the next slide, what are the challenges here? Okay, we've talked about a lot of challenges, but in this instance, we asked in a specific question, what are the challenges? So 30% said the total cost of operations. Now, what does that mean? Well, organizations are spending more every year. Last year, our research indicated that 62% of organizations increased their cybersecurity spending. This is a measure of what am I getting for my money. So the total cost of operations is high, and my return on investment on security technologies is low. Now, that's not a recipe for success. That's certainly not something that's going to make a CFO happy. And as security professionals, we have to be much more sensitive to this moving forward. Am I getting bang for my buck when I spend money? And do the security solutions that I add new, do they actually make the security solutions I already have in the network better? Or is it just an additional tool? We have to ask ourselves that every time. The next one really disturbs me. So 27% of those that we surveyed said that the cybersecurity team at my organization spends most of its time addressing high priority or emergency issues and not enough time on strategy and process improvement. That's firefighting. We're spending all of our time fighting fires. And yes, that's admirable, and people deserve a pat in the back. But first of all, it burns out our people. And second of all, you can't keep up. If the volume of security alerts is going up, you're leaving fires burning, you're attending to what you perceive to be the big fires, leaving other fires to burn or burn out themselves. Well, they don't burn out themselves. And the fires that seem to be small may be where the bad guys are hiding. So emergency firefighting is not a good way to approach security operations. In fact, it's a terrible way to approach security operations. 23% say it takes too long for my organization to remediate security incidents. Of course, you have to detect the incidents first, and we know dwell times can be months or, in the case of Marriott that we just saw, years. And then once we detect them, we have to get to root cause, we have to understand the scope of these incidents, and then we have to remediate them in concert generally with IT operations. So we need ticketing systems and case management systems and lifecycle management between these two departments. That has to be efficient and effective. It's not always the case. Now, you'll see a pattern here. There's a lot of data on these slides. I won't get to it all. I believe Empower will make these slides available. So if you want to see them and take a look at them, get back to me with questions, that's fine too. Go to the next slide, please. So this summarizes where we are, and it's not a pretty picture. It's what the data says. So we know that security operations is becoming more difficult. It's more difficult today than it was 2 years ago. It's probably safe to assume that it will be more difficult in 2020 than it is in 2018. We have too many point tools. I'll go to the third bullet, as was evidenced by our research. Typically, an enterprise around 30 point tools. Those have to be managed separately. They each have their own consoles. They each have their own configuration management. Typically, they need some type of skills or training, so that doesn't scale. And when I'm managing all of these different tools one by one, I have too many manual processes. I don't have automation. I don't have intelligence. And with a lack of people, as you can see, not enough staff, inappropriate skills, this does not scale. So if we go on to the next slide, there's some debate in the world as to whether Albert Einstein actually said this, but let's leave that aside for a moment. It really does speak to, if you go back, if it really does speak to the situation at hand. The definition of insanity is doing the same thing over and over again and expecting different results. That's what we're doing. Unfortunately, with security operations, we're buying new detection tools that add to the complexity of security operations. We're not integrating our tools, so we have to manage them one at a time. The new tool doesn't add incremental value to the old tools. Things don't scale. So we need to kind of get out of the box that we're in right now with security operations and look for some alternative paths, alternative technologies. If we go on to the next slide, here's some of the things that people are doing. So one of the things, and I mentioned this before, is they're spending more money. So 33% are say they will increase spending on security analytics and operations by a significant amount, and 48% say that spending will increase somewhat. So 81% of those we surveyed will increase spending on security analytics and operations. Now, as the research pointed out, the cost of operations is one of our biggest challenges. So we have to be smarter in the way we spend. Again, we have to look for investments that add value to what we already have, that make what we already have much more effective and much more efficient. And in that way, we get the ROI on our spending. So there is money here. We have to spend it wisely. If we go to the next slide, please. Here's another thing that we need to think about as we look for the next generation of security operations tools and sort of next generation SIMs. So this, I'll summarize the question. We're asking, will your organization collect, process, and analyze more data in the future, more cybersecurity data in the future, about the same or less? And if you go all the way to the left, you see 28% say we collect substantially more data to support our cybersecurity analytics operations today than we did 2 years ago. So once again, sort of the contrast between today and 2 years ago. And 49% say we collect somewhat more data. What kind of data? Threat intelligence, more data and logging from some of these detection tools. Network packet collection, metadata on the network, flow data, DNS logs. There's no shortage of things we can collect. So if we're collecting all of this data, it really makes sense to have some kind of a security operations architecture that can scale, that can be effective with this kind of growing data pipeline that's built for analysis of big data, so some data science behind it, some intelligence behind it, because this is what's here. It's not even what's coming. Is that cybersecurity and security operations is a big data problem, so we have to have big data solutions to address it. Go to the next slide. So what's needed? This is sort of a general description of what's needed at a high level. So number one, rapid time to value. There are only so many projects that cybersecurity teams can take on that will take 2 years to implement and take massive amounts of training and will take customization of the solution. Now, SIM was very effective in its time, but rapid time to value is not a characteristic of SIM. SIMs do have to be customized. You do have to train people. You do have to build dashboards or correlation rules. And that takes time. It takes investment. And as you could see by our objectives, organizations want to improve their threat detection and response. Well, they really don't have the luxury of time to do that. So how can we do that in a much more timely fashion? What's needed is a force multiplier that leverages existing security controls. So this is the architectural requirement. Our detection engines in place today need to be made better. So that's the force multiplier effect. So can we find tools that aggregate what we have, add value to what we have, correlate different information from different tools, and improve the accuracy of our detection and the efficiency of our response? Massive scale to accommodate terabytes up to petabytes of data. And typically we want to retain that data longer for forensic investigations over a long period of time. Advanced intelligence and insight. Tools are being built around artificial intelligence, more accurately machine learning. So we need our tools to be designed by data scientists. We need machine learning algorithms, and it's all to sort of weed out the false positives but also give us more context over the alerting so that we have a breadcrumb trail of issues that lead to the alerts. We understand what the root causes are. We understand the scope, and we can remediate those things faster. And speaking of remediation, we do need automation. Now, the best way to describe automation in cybersecurity is there's a lot of repetitive processes. And so it's not about automating the task we do once a week that takes us 2 hours. It's about the tasks, automating the tasks we do every day, multiple times a day that take us 10 minutes. So cumulatively, we're spending a lot of time on these things. It doesn't scale. We want to get rid of these manual processes. So we need tools that support a degree of automation and a flexible degree so that we can start to automate some of the really difficult things and then move forward and automate more and more with the goal of automating as much as possible over time. Let's go to the next slide, please. So this is the SOPA architecture, and it's described fairly simply here. There are a lot of words on this slide, so I'll try to describe what we're after. So the first thing is, if you start at the bottom, we talked about the data growth. So there is a tremendous amount of telemetry associated with security, and there are different areas or data flows or data capture that I'm examples that I'm listing here. And those need to be collected and processed in with some kind of common distributed data service. So all the data flows into this data services layer. The data is then available. And it's made available in the right format to some of the tools above. Now, part of the way it's done that happens is through a software services and integration layer. Think of that sort of in classical software terms as middleware. So things like a message bus or a transaction processing hub, a publish and subscribe, so that the data is available, that we don't have to build these vertical stacks to collect and process and analyze the data. The data becomes available to the analytics layer. Now, analytics can be lots of different things. We can do analytics for risk management purposes, for threat detection purposes. We can do investigations. We can do threat hunting. But all the data is made available to that layer, and we can just plug that into the software services and integration layer, or that bus. And then on top of that is what some people call SOAR, but automation and orchestration. So we've analyzed the data. We now know where the threats are. How do we respond to those threats? And how do we do that in an orchestrated way where we can put controls on lots of different, or put enforcement policies on lots of different controls, and we can automate processes. And that automated processes can also work with things like the IT operations team. So that SOAR layer kind of sits on top, and there's usually a feedback loop into the security controls themselves. On the left side, these layers should be able to be on site, or they also should be able to work with cloud-based applications as well. So there's a lot of APIs, there's a lot of sharing of data, a lot of integration of tools. So if you go to the next slide, please. So the bigger truth is my summary and conclusion. I hope this was helpful. Current security operations are not working. We see that things are getting more difficult. We see lots of challenges. We see a very mediocre return on investment. So we need to make improvements. And organizations must improve the security efficacy and operational efficiency of their tools. This involves things like technology consolidation and integration. So really, again, getting more value out of all of the security tools that we have by making them communicate and work together. Automation and orchestration. We have too many manual processes, not enough people. We need to have our tools work together collectively to not only detect problems, but also remediate problems, and also change our controls to respond to new risks. And that will include advanced analytics like machine learning, which we're starting to get more and more progress on. I think 2019 will be a big year for that. The market's moving to SOPA through solutions like Empow, through consolidation of different tools. But I see a lot of activity there, and really there's no other way that we can do this. We need integrated architectures, and SOAP is an example. And there's plenty of room for innovation. I'd say that CISOs should cast a wide net. There are some established solutions out there, but there are a lot of new innovative solutions as well. And the goal should be, as we said, consolidation, integration, automation, and orchestration, advanced analytics, really getting more out of your technology, more efficiency, more effectiveness. So with that, thank you very much, and let me turn it over to Avi.
Thank you very much, John. My name is Avi Chesla. I'm the CEO and founder at Empow Cybersecurity. As John mentioned, we have developed a platform, and what we say, a security platform, and what we say is that we can turn what organizations already have, including their data sources, security tools, and the entire infrastructure, into what they need in the security world. Shortly about the company, Empow is an Israeli-based cybersecurity company. Our development center is located in Tel Aviv, and we have a Boston, our headquarters is in Boston. We are running from here all our sales, marketing, and support operations. We founded the company almost 4 years ago in the end of 2014, heavily investing in advanced analytics, have more than 16 patents, 6 already granted in the field of security analytics, which we will talk about in the following slides. Our approach and solution is all what the market talk about or define today as a next generation SIEM, which includes the capability and the technology to identify not only the known attack patterns, but also the unknown sequences and new patterns of attack without requirement of constantly maintain and obviously create security correlation rules to make your security platform effective. We have customers around the world. We focus in North America, medium to large enterprises, and in telcos organization as well. And let's continue and talk about our positioning first. So following what John said about the consolidation in the market, there is a requirement to consolidate platforms. And I'm not talking about the security tools themselves. Of course, there are hundreds of different security tools in the network. But there is also in the last few years a trend that creates new platform and analytics platform that sits on top of the current security configuration, including threat intelligence platform, the TIP, EDR, endpoint detection and response platform, UEBA platform, SOAR platforms, and more. And these are too many platforms to handle by a typical security operations centers. It's make it very complex and expensive to make all the organization effective and to react quick enough against advanced attacks. So the consolidation trend that we see, and this is what we identified almost 5 years ago before we founded the company, is that this platform need to consolidate. And we start from the basic SIEM, the SIEM. Obviously, it's needed because this is a platform that should have the capacity to collect all the logs and pieces of data from the IT infrastructure, aggregate, store it, and allow very fast search. Some of the analysts in the market call it the CLM, the centralized log management, and this is the basics. The problem with this platform is that they require a lot of experience, expertise, and money in order to make them effective in detecting attacks. In order to detect attacks, this platform require you to create manually and statically security correlation rules. And this is something that is very hard to scale and a very reactive approach. We in Empower have established this database that know how to collect all the data, what we call the data lake. We have an OEM relationship with Elasticsearch, the company, which make our solution a very scalable and robust data lake. Another portion that everybody is talking about and what I mentioned about network traffic anomaly and UEBA become mandatory to be part of the same platform in order to be able to understand the unusual activities, not based on specific patterns, known patterns of attack, and not based on security events and security logs. You need to have the capability to profile the network patterns as well as the user activity in your network, and then flag about anomalies and what the market call it, the user entity behavior analytics and network traffic analytics. The issues with these technologies is that if they are coming as a standalone solution, they can flood you with a lot of noise and false positive, because making decision only based on deviation from normal patterns of behavior is susceptible of a lot of false positive. And this is why we need platform that will able to correlate these suspicious alerts of behavior with other alerts that will provide more context, which will make the alert much more actionable. The third part of the SIEM, or the next generation SIEM, as we call it, is the SOAR, the orchestration automation part. In order to react, in order to respond very quickly in terms of investigating the incident, validating it, and creating response action, you need a mechanism that allow you to automate these workflows. All of these need to be integrated together. And we in Empower build a system, which now the market calls the next generation SIEM, that was designed to consolidate all these technologies from day one, make them working with tight integration in a great sync. The issues with these platform that other platforms that are not Empower is that they still require to create and maintain a lot of security correlation rules. Otherwise, they become really ineffective. And in short, Empower created this next generation SIEM that consolidate all these platforms together, powered by artificial intelligence and specific field that we've invested in, which is natural language processing, NLP algorithm, allow us to provide a platform that does not require to create and maintain security correlation rules. And we'll talk how we do it in the following slides. So first of all, the main challenge that I want to address here and explain here is what are the security analysts need to do, or how we can actually provide good answers and effective analysis, which mean understanding what is the attacker intent that is hiding behind all these pieces of data and security logs and other raw logs that the infrastructure is generating all the time. We call it the malicious attacker intent. And they must be able to search for logs that provide these motivations. So let's take an example of an analyst today. The analyst today sits on top of his SIEM and other security analytics platform and asks himself, according to my business or organization that I work for, what are the attacker intents that I need to look for and identify quickly as much as possible? Attacker intent examples are given here in that slide, from external intelligence reconnaissance to internal ones, different types of external delivery types into the organization, from different types of phishing campaigns and others. alerts that present local or remote privilege escalation, different types of data leak, including data scraping that focus on personal records, financial data scraping, focus on social security numbers, credit card numbers, and more, and other types of these malicious intents. So this is what they are looking for. In reality, in order to find if these type of incidents or attacks are being developed inside the organization, they need to know what to look for, what to search in the huge amount of data that they are collecting. So they need to know what are the clues, what are the patterns, attack names, file hashes, intrusion names and types, malicious URL, and more, attack tools, and so on, that actually serve the attacker intent they want to focus on against specific assets in their organization. And if they know these clues, if they know these patterns, based on research that they're doing or feeds that they're getting, they can try to search for it inside the data. If they identify, it's good. And this is an example. If they want, for example, to search for an attacker intent that associated with financial data scraping, they should know that a name of a malware called W32 Ramnit, for example, this specific malware serve the intent of financial stealware. They should actually know that. And the main challenge here that they have, especially in the recent years, is that these malwares, these phishing and malicious URL, these attack tools and intrusions are being created in a massive way every day. They are all the time changing. So in reality, if they know what to search, it's already old. It's already trying to understanding the attack pattern of the past. Because these patterns, including the names, the hashes, the URL, and these logs that represent them, become a moving target. So that's become an impossible mission for a security analyst to use all that data and search for it. And it doesn't matter how much this database of logs can scale, how fast the search function are. It's all important. But if he doesn't know what to search for, his approach becomes very reactive to the security. So what we are providing with Empower is a way out of this problem. We have developed the natural language processing classifiers, which allow to index all the data on the fly that is coming from the data, from the IT infrastructure, from the security tools, from different data sources that he has in the network, according to attacker intent. So we change the situation here because the data now that is available for the security analyst is enriched with an attacker intent, and it becomes searchable. So now this analyst doesn't need to deal with all these names of malwares and URLs and all that are changing every day very rapidly, and actually search for an attacker intent. And the system that we have developed allows to enrich all the existing logs and new logs with this intent. What we get here is, of course, much faster detection investigation, so time to detect and validate incidents reduced dramatically. And not less important, all the system become much more up-to-date and proactive. They don't need to fight against pattern of historical patterns that maybe are not longer relevant. So let's go a little bit discuss about natural language processing. As I mentioned before, this is a field in artificial intelligence that was developed by the artificial intelligence community in the last few years. and become very effective and mature in other areas like speech recognition and text classification. It's become very accurate. Example includes Alexa, includes Siri, and other very known applications that are working very well using natural language processing methods. It's basically allow a machine, and in this case, our next generation SIM, to process both structured and unstructured data that, of course, the IT infrastructure generate all the time, and reach into conclusion. So automate, in case of cybersecurity, the thinking process of a security analyst. So let's take a very simple use case and a correlation rule that you would like to create in your SIM today. So in existing SIM technologies, including the one that also call themselves next generation SIM, you still need to create a rule in order to identify this type of anomaly. For example, host is a victim to an intrusion that can lead to privilege escalation, followed by a brute force attack, or the other way around. And then the same host or user account start to generate unusual account activity. This is something that every security analyst will want to know about and continue and decide if you need to remediate here the host or not. In reality, in order to implement such basic rules that cover this security use case, you need more than between 100 to 1,000 static human-defined security correlation rules. And why is that? Because there are many data sources and tools, like John showed before. Each one of them generate different types of alerts and logs in different language, which can represent each one of these attacker intents. The data is very dynamic, meaning that there are new malwares, new malicious URLs, new attack tools and intrusion every day that are created in order to serve this attacker intent of privilege escalation or brute force attack or some unusual account activities. So in reality, this security platform, the SIM, require a lot of security expertise and become very reactive because of that. So we develop a system that allow you, by using AI and NLP, to classify automatically the data that the IT infrastructure generate. And this classification result is an attacker intent. So we have here attacker intent A, which is a privilege escalation, B, which is a brute force attack, and C, which is some unusual account activities. And we have trained these natural language processing classifiers to scan the logs, to scan and read the content within each one of the logs, and automatically understand if these logs can be associated with one of these attacker intents. And that can be generated by multiple tools. Each tool can generate new types of log with new content. These classifiers will learn to understand it in any case. So as illustrated here in the build-up of this slide, these classifiers were trained to understand attacker intent A, which is privilege escalation. So any log, any piece of data that can give us a clue about possible privilege escalation is being classified as such. If there is not enough information inside the log, and many times this is the case, your security tools just say something very vaguely about the attack name and maybe give some hash that was represent the file that was analyzed, but not more than that. We know how to go into third-party threat centers, what you see here on the right of this slide, and automatically collect threat intelligence that is relevant for this log that we are analyzing. enriching it with this threat intelligence data, and let our classifier to read this data instead of the security analyst and classify the log accordingly. So the system works not only based on the data that you have in your network and within the logs that we collect, but also based on external information that we are getting. That's to show you how the whole process works as a one system, because we talked only about one part, which is critical part, but to understand the full cycle of collecting logs, classifying them, and then detect and respond, let's go through this slide. The first, what you see here is that stage is that we sit on top of all the data sources, including security tools and raw data, including security logs, raw logs, network flows, and threat intelligence feeds. And the first thing that we are doing, as I mentioned, by using NLP, is to classify the attacker intent associated with each one of these logs. Sometimes it can be done by a single log, and sometimes it's based on a collection of logs. So for example, to classify security events, it can be done based on singular alert. If we are talking about a suspicious behavior of the entity or based on traffic, it will be based on entity anomaly classification that will collect a group of logs that represent an abnormal behavior based on what was learned before. And the same goes to network traffic patterns between the entities. So in order to have a full spectrum of classification of threats, of attacker intent, we have a technology that addresses the classification of your security logs, including your IDSs, anti-malware, antiviruses, threat intelligence feeds, and more, as well as raw logs that are being like operating system log and application logs that are being handled by entity anomaly classification technologies, as well as traffic logs and flows that are being analyzed by the traffic anomaly classification, the network traffic analytics. Once the attacker intent is known, the next step is to correlate all these intents together, because maybe they are not relevant. Of course, there is a lot of false positive and noise, but only if there is some cause and effect relationship between these attacker intent, which provide an evidence that an incident is being developed into a real attack, we can prioritize it. We call it an attack story. And we tell the attack story visually, in real time, according to the availability of the logs, and prioritize the real attack above all these noise and false positive. And not less important, focus on attacker intent that the user, that the customer want to focus on, not just on any type of attack. And the last portion of that, the last stage, is to automate investigation and further response activities using our built-in orchestration engine in order to close the loop and be able to investigate as well as block the attack in the context of the attacker intent, in the context of the attack story. I want to summarize by showing the architecture, high-level architecture, very general one, of how we have integrated our security intelligence inside and within the Elastic Stack. So what we have done, we have developed what we call the intent-based plugin that is being integrated into the soundbound interfaces and layer of the Elastic Stack, the Elasticsearch stack, in order to allow to collect logs, classify them on the fly, And based on that, to enrich the database, the Elasticsearch database, which is our data repository in Data Lake, with intent metadata. It means that we are index the data, including the attacker intent, which make it searchable in a much more optimized and effective way for any kind of forensics and investigation reasons and search. On top of that, we have integrated our next generation SIEM security intelligence layer that includes the user entity behavior analytics, network traffic analytics, and cause and effect models that know how to automatically correlate the logs without the need to create and maintain these hundreds and thousands of security correlation rules. And that allow to provide a SIEM empowered by the data lake of Elastic with advanced analytics, what we call the intent-based next generation SIEM. A SIEM that allow you to have a system that is proactive and not reactive, because it does not mandate to create manually and statically and maintain all these correlation rules. You can do that. We provide you the language to create your correlation rules, but it's not a necessity. And this is how we know to provide you a system that will detect also the unknown, with much less maintenance and expertise requirements. We provide the full feature set of the Elastic on top of our system, including alerting, machine learning, reporting, and graph if needed. So just to summarize, if we need to compare the existing situation with the SIEM solution today, comparing to a next generation SIEM provided by Empower, we can summarize that we provide a system that out of the box provide a very wide security coverage, meaning that we cover a lot of security use cases. And more important than that, it's proactive. You don't need to create new rules in order to address new use cases on the security front. We develop a system that can automate the decision-making processes of investigation and response based on attacker intent, based on the context of the attack, which require less rules, less playbooks to create and tune. Overall, we see in our customer environment a reduction of more than 90% of noise and false positive in the entire cybersecurity system that they have because of our system. And we provide the best-in-class data lake with very large community that enrich it based on the Elastic users, with new plugins, new type of dashboards, and so on. And I'm going to the last bullet here. You might know that most of the security, the SIEM technologies that exist in the market provide pricing models which are based on data volume, data consumption, or events per second. This is a very unpredictable and not scalable approach, very expensive, of course. Our pricing model is based on the organization size, which means the number of hosts that are or are needed to be protected. Very predictable, of course, and cost effective in terms of the budgeting. So thank you very much, and let's can open that for any question you might have.
Avi?
Yes.
So this is John Olstik, and I'll ask a question as a proxy for what I'm hearing from users, and that is, if you have an existing SIEM, can you use a solution like Empower in conjunction with the SIEM?
Yes, thank you. So We have existing customers that already have a SIM, and we know how to work with that. There are different ways, and I think the most trivial for us is to forward alerts and logs from the existing SIM that acts more like a data repository for log retention and compliance and forensics needs, and forward us the logs for more advanced analytics and automation purposes. So this is a typical deployment. We work on top of different SIM technologies in the market, some of them coming from very big vendors, which you can imagine. So I get another question here. Let me just read it for everybody. What is the biggest pushback from organization exploring Empower? So let me start by saying that we introduced the solution about a year and a half ago, maybe a little bit more, with a beta version in 2017. And the biggest pushback in the beginning was that, you know, this story that we tell seems to be too good to be true, because they are really used to the old-fashioned way of using SIM, creating correlation rules that will create context for them. And the fact that we are coming with a system that virtually reduces this need and have a system with virtually no security correlation rules and still be effective was look too good to be true, as I said. So that maybe was the major pushback. And the only way for us, in order to prove that we can do it, was through what we call the POV process, the proof of value process, that we deploy the system on top of the current data set of the organization that they already have, including the logs and the data that they collected or collecting in real time, and prove them that if they put us in front of Splunk, LogRhythm, IBM Curator, all the other old-fashioned SIM that are taking the approach of the security correlation rules, the manual rules, static parsers, and all that, and showing them that with not more than 3 or 4 defense model, what we call, which include very few rules, we can cover much more and detect, in reality, much more security use cases based on the data that they have, versus another system that is another SIM there that contain hundreds, and as I mentioned before, sometimes 2,000 and even 3,000 security correlation rules and log parsers rules and things like that. So that was very impressive for the organization. This is why they selected Empower. Another question that I see here and that is coming up is, what are the other next generation SIM technology that we have seen so far? I think that this is the following to the same question. Today it's coming from different direction. You know, next generation SIM, obviously, no system that came from started as a UEBA, user entity behavior analytics. Some of them started as a network traffic analytics system, and understood that in order to create a solution that is much more actionable, with less noise and false positive, they need to provide greater context. And this is why they start to develop engines that integrate their feeds, their alerts, based on these analytics engine with third-party security tools and other types of system that include in the enterprise and the IT infrastructure. And these companies call themselves also today next generation SIM because they include the UEBA or network traffic analytics or both, and some automation and third-party correlation rules. Companies like Exabeam, Rapid7, dark trace, and a few others are part of these next generation SIEM technologies. And another question that we have here is, what have been the most common use case for deploying Empower based on our experience? So obviously this SIEM technology in general, and of course also next generation, cover a lot of use cases in different industries. We can tell you that the most popular use case for Empower was pretty simple. And the basic thing that they required from us is to be able to automatically prioritize entities and hosts that are compromised in the organization based on an analytics engine, these user-based entities, based on network traffic anomalies, and based on the correlation with threat intelligence feeds and other security logs they are getting from the security tools that they have. So a simple dashboard that show them the top list of entities with the highest risk for the company and what type of attacker intent involved in that was a simple use case that was always most popular and the major or main success criteria for a pilot, and then later on for all the other security operational needs. Thank you. Thank you all for joining the webinar today. And if you have any further question, we'll be happy, of course, to follow up. You have the email details, and we'll be happy